Alright, so we have only Kian and Gursan. I don't know whether that's a good news or bad news. So let me just send a reminder to everybody. And okay, here comes Manas. Manas, you did not go anywhere for spring break. Okay, class is starting. Alright, so what we will do is, I'm afraid that no, we'll have less presence in the class. Only few kids are going to join because I got the message from Grihita and Vivan that they both are not joining today. So what we will do is we will give, I will give you guys the opportunity to pick a topic of your choice and we will cover that. So let's say Kian says, I want you to explain this topic, okay, which I have doubt about. Gursan says, I want you to explain this topic. And then let's say Manas has some other topic. We'll cover all the three in an easier way to make sure that you guys are comfortable with that. So that way, no, I'm able to give more attention to you guys because we have less people. Solving inequalities. So Manas has given me one work. Okay. Let's see what Kian and Gursan wants. Yes, Gursan, go ahead.
So in class right now we're learning about solving quadratics, and I know how to do it, but I get given the class.
Okay.
So we're learning about how to complete the square.
Okay.
Solve it.
Okay, so solving quadratics. Okay, we have Suchit also in the class. I will give a candy to Suchit today. I was missing in the class. Good to see you.
Yeah, me too, sir.
Okay. Alright. So we have less kids in the class today, okay? And I'm assuming that we'll not have many other kids joining. So that's why I'm giving everybody a chance to pick a topic of their choice and we'll cover that at conceptual level. So Gursan wants to talk about quadratic. Manas wants to talk about inequality. What about Kian and Suchit? Kian, what is coming to your mind? What is the topic that is bothering you that you want to cover today?
Sir, I don't know. I don't have any topic that's bothering me right now.
Okay, so then you will learn what I'm teaching Gursan, quadratics. Okay, and then
I want to do it.
okay. All right. So Manas wants to learn about inequalities. So Manas, stop taking that face. Be normal. Let's be a math kid right now. We are not doing any, what do you call, anything related to acting or anything interesting. We'll do only math. So first of all, let's catch up on inequality first. Manas, tell me what is that you know about inequality. Let's see.
Well, a few examples of inequalities are less than or equal to, greater than or equal to, less than, greater than or equal to.
No equal to. Keep the equal to aside. So I'll break it down. Okay. Now let's look at inequality in a very simple way.
It's something that's not equal to another.
Exactly.
It's in the name. I
It's,
just realized that.
yeah. So if I say appropriate, something that is okay. Appropriate, you say this is appropriate, this is fine. I put an in again next to it. Inappropriate, which is not appropriate. This just changes the meaning from yes to no. Make sense? So, if I am talking about equality, if I am saying I need to ensure equality in the class, meaning I need to be equal, or I want everybody to be equal in the class. I want to make sure that I am paying equal attention to everybody. That is where I am ensuring equality. If I want to be a bad teacher, I am saying I want to ensure inequality in the class, meaning I want to be stupid, partial, unreasonable, whatever you can think of. Yeah. So now let's keep English aside and let's think about math. So Marco, shift a little bit so that I can make eye contact with you. That's better for me. Okay. So here today we have less number of kids in the class because your friend Vivan did not turn up. He has gone for a trip. Havisha is not here. Grihita is not here, and I see Om, Anahita, and Adya and Aritri also not here. So many other kids are missing. So that's why you guys have an opportunity to pick something of your choice. So Manas wanted to talk about inequality, and Gurshan and Suchit want to talk about quadratics. So these are the two topics that we'll cover today. Okay? So right now talk about inequality actually. Okay. Now I just started with what do you mean by equality? If I'm saying Manas, don't keep turning on and off your video. Okay. Keep it stable. Don't touch your screen even. Okay. Focus on whatever speech I'm giving or whatever is there on the board. So when we talk about equality, if I'm saying I want to ensure equality in the class, meaning I want to be fair. Similarly, in mathematical terms, you don't want to write that big a letter. You are saying this is equality. You are saying that if I ever say 5 is equal to 4, what will you do? You have one best solution, change the teacher. This is not equality. This is not equal.
Yeah, so you just put a line through it, right?
I'm sorry?
Put a line through the equal sign?
No. So this is, if I'm saying 5 is equal to 4, this is not right. I can say x equal to 12, that's okay.
Yeah.
I'm saying that okay, value of x and 12 are same. That's why this is equal to.
Yeah, because x is a variable.
Yeah, it's a variable. So in simple terms, when I'm putting an equal to sign, I'm comparing two things which are exactly the same, which have same value, same meaning, same output. So I can represent equality in different ways. I can say 9 is equal to 5 plus 4. I can say x equal to y plus 3. I can say z equal to x plus y. In this case, I have constants that I'm adding and comparing. Okay. Is 9 equal to 5 plus 4? Yes, this is the right representation of equality. If I'm looking at this one, I'm looking at two variables, x and y. And what this whole statement says is, the value of x is equal to value of y plus 3. So if y decides to be 2, value of x will become 5. If y decides to become 1 million, value of x will be 1 million plus 3. Yeah. So we are representing equality here, where you have something on left hand side, something on the right hand side, and both are same. Yeah. This is a basic representation of equality. Now let's not talk about constant, we'll only talk with respect to variables. If I say x plus y equal to 9, meaning value of x and value of y together is giving me this output. This is equal to. I'm saying, you know what? I don't want to talk about equality. I'm saying x plus y is less than 9. Now you can play with all the possible values of x and y, but the condition here is sum of that has to be less than 9. Yeah? We are not talking about equality. I can also talk about x plus y is greater than 9. This is also not equal. I'm saying any value x and y together is going to be more than 9. Be it 9.1, 9.000001 or 25,000. Doesn't matter. Anything and everything possible which is more than 9 is acceptable as per this one. So all these signs which are not exactly equal to sign represent inequality. So you will talk about less than, greater than equal to, less than equal to. These are 4 scenarios that you will talk about when it comes to representing inequality. Does it make sense? Manas, are you clear about it?
Yes, sir.
Okay. Now, how does it play a role? I'll give a very simple example. I'm certainly not, see, if I talk about inequality alone, I can take a 4-hour class to touch each and every piece of it. Just because we're trying to get a concept around this topic, let me give you guys some example. Okay. So, are you guys okay?
Yes, sir.
Now, what does equality do for us? Let's say if I'm talking about x equal to 10. Just an equality example where we say value of x is 10. If I visualize this in a coordinate plane, let me get another model. If I visualize this in a coordinate plane, let's see what happens. If I am talking about x equal to 10, let's say this is 5, this is 10, this is 15, this is 20. Minus 5, minus 10, minus 15, minus 20. If I am talking about x equal to 10, what exactly is going to represent on the coordinate plane? It is saying this represents a relationship where at every point the value of x is 10. So you are essentially looking at this line. Here, if you come to this point, you will see your x value is 10. You come to this point, your x value is 10. You come to this point, x value is 10. You come to this point, x value is 10. If I keep stretching it, this line x equal to 10 is represented by this line. Because we are only worried about the value of x. We are not worried about value of y. Everything here is representing x equal to 10. Now, if I say, let me change this little bit, and since we are talking about coordinate plane, only x makes it look little incomplete. Let's say x plus y equal to, let's say, 8. Still representing equality. Now, when I have an equation like this, what it is saying is, your value of x and y together will be 8. If you want to keep x equal to 1, y will change to 7, so that together it is 8. If you change x to 2, y will become 6, so that 2 plus 6 is 8. You change x, you are being very playful. You say, okay, my x is minus 50. When you say x equal to minus 50 plus y has to be 58, so has to be 8. So your y will become 58. They are changing values to make sure that this agreement is not breached. So for me, any and every equation is nothing but an agreement between the variables. Okay? Is that sounding okay? So let's look at what are the possible options. See, we are just playing with this, okay? We are not doing anything serious. What about x equal to 0? Oh, when x is 0, your y is 8. That is how these two are adding up to become 8. When x is 1, what happens? 1 plus y equal to 8. So y has to be 7. When x is 5, 5 plus 3, that is how you will get an 8. Let's be a little more playful. When x is minus 2, when x is minus 2, this has to be 10. That is how this will add up to become 8. Right? When let's say x is, let's play with y again. Now, if y is 0, what happens? When y is 0, x has to be 8. So we got 5-6 combinations of x and y values. Okay? Everybody seeing that. And if I have a lot of time to waste, let's say I'm enjoying this wastage of time. I want to waste another 2 hours. I will make it a long table with 5,000 rows, and I will have that many combination of x and y values. Okay. Thankfully, I'm not trying to waste everybody's time, so I just stayed with 5. Now let's see what that means to us in a coordinate plane. When x is 0, y is 8. So this is where x is 0, y is 8. Let's say 2, 4, 6, 8, 10. Here it's minus 2, minus 4, minus 6, minus 8, minus 10. When x is 0, y is 8. So I'm looking at this point. This is 1 point. When x is 1, y is 7. So when x is 1, maybe somewhere here, y is 7. Somewhere here. When x is 5, y is 3. When x is 5, y is 3. When x is minus 2, it's somewhere here, y is 10. What you're saying is here.
Oh.
When x is 8, y is 0. When x is here 8, y is 0.
It's a line.
It will be a line only. It will draw a line for us.
So
Okay.
if you give x and y like a certain value, will it always be a line?
It will always be a line. So here, now the one good takeaway is, if you are looking at any equation, we tried plotting x plus y equal to 8. If I say 2x plus y equal to 19, or 17x minus y over 2 equal to 15, or if I have equation like x by 9 minus y by 27 equal to 1, whatever be the case, these are all called linear equations. These are called linear equations, meaning if you have an equation with two variables x and y, where the maximum power to x is 1, maximum power to the variable is 1. Here, if I am writing x, I can write this as x to the power 1. If I am writing x squared, that is x into x, right? So here, if I am just writing a variable without any power, I am talking about power 1. So the catch here is, if you have any equation where the maximum power to the variable is 1, that's going to be a linear equation. Meaning, when you take this equation and create this table of x and y values, it will draw a straight line for us. That's the reason why it's called linear equation. Okay? Marco, okay? So, even if I wake you guys up in the middle of the night and say I have 4x plus 7y equal to 5000, is it a linear equation or not? Your answer would be yes, it's a linear equation. Because only thing that you're going to be concerned about is the power of the variable. Both the variables have power 1. No second thought. This is a linear equation. Okay? Now, let's keep this aside. Now let's come to this equation. So we drew this line. What this line means to us, see, we just joined these points that we imagined, and we connected them and drew a line for us. What this means is, though we picked only 5 points, but you are having infinite points on the line. You cannot count how many dots are there. Every dot is representing x and y value. Every dot has x and y coordinates. So when you have a linear equation, you are looking at infinite number of solutions, infinite combinations of x and y values. Does it make sense? Unless somebody says this line has only 15,000 points. If somebody is intelligent enough to say so, then I will agree to it. But I don't think that's a possibility. You cannot count. Even a line segment is made of how many dots, how many points. Points are something unmeasurable. Yep. So this was the line. Now the question is this what is inequality? No. This is equality only. Now, to make it look like inequality, I have to put a less than or greater than, less than, equal to, greater than, equal to. Now this is the situation. Is this inequality drawing this line? No. This is not drawing the line. We are not talking about x plus y equal to 8. We are talking about x plus y less than 8. So what is that is representing now for us? So your approach would be this. You have this equation, inequality, x plus y less than 8. What you did was, you made it equal to and then created this table and drew this line. Now you are trying to find out if this was less than 8, what scenario I'm talking about. I'm certainly not talking about this line because this is not same as this one, right? So what we will do is, we'll pick some points. Let's pick one point here, some extreme points, okay? If I'm picking this point, what is the x and y value of this one? Minus 15 is x value and 0 is the y value.
Wait, oh yeah.
Yeah? And I'm trying to check if this point is satisfying this condition or not. My x is minus 15. Minus 15, y value is 0, is less than 8. Is this looking correct?
Yes.
It looks correct. Okay, so basically I'm talking about something in this side of it. Let's pick up another point. Let's pick up 0, 0. Put 0, 0 here. So x is 0, y is 0. Oh, that is also less than 8. So this point is also correct. Let's pick this point, minus 5, 2. So my x is minus 5 and y is 2. Minus 5 plus 2 is minus 3. Is this less than 8? Yes, that is correct. So what it is telling us is, this whole region, any point in this region is getting represented by this inequality. And you can check that. Don't blindly believe your teacher. Yes.
Can't you also like have points in the second quadrant?
I don't care about it. I'm saying, based on the evaluation we have done, we see that
Oh.
anything below this is satisfying this condition. Now to your point, second quadrant.
Yeah,
This is second quadrant. This is covered. This is third quadrant. This is covered. Even you have some points in the fourth quadrant also covered as part of this one. Let's pick up this point here. Minus 10, 5. So this one has coordinates 5 x value and minus 10 as y value. If I put this here in this equation, x is 5 plus minus 10. How much this is? This is 5 minus 10. This is minus 5. Is it not less than 8? Yes, it is. So basically you are covering even first, second, third and fourth quadrant. I'm not worried about the quadrant. I'm only worried about what is coming below this line.
So everything below this.
Everything below this line. And I would not say that if it is less than sign, everything below. No, you will not make that judgment. You will just pick randomly a point. Let's say whatever I'm saying is not correct. If I'm saying that everything below this line is satisfying this condition, that is not correct. Let's pick this point, 20, 0. I'm just picking extreme points so that it makes us do the right judgment. So this point has coordinates 20, 0. Correct? X is 20, y is 0 here. Let's plug it here. 20 plus 0. This is 20. Is this less than 8?
No.
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 So that means anything above this line is not correct. You want to check one more thing. Let's pick up a point on this line itself. Let's pick up this point, 8, 0, which is falling on this line, and see if that satisfies this condition. So this point is 0, 8. X value is 0 and y value is 8. If I plug it here, x is 0 plus y is 8. 8 is less than 8. When did that happen? Never. So the points on the line is not satisfying this condition because my inequality says so. If I had less than equal to 8, then yes, this will satisfy. So then this line is included and everything below that is also included. Okay? Does it make sense to everybody or I have to scratch my head more? Makes sense? 100%? Manas, okay?
I don't get much.
So then you have to, what is that you did not get? It's very easy to say I did not understand anything. Teacher is horrible. What is that you did? Tell me. Why that is coming as a feedback after 26 minutes of blabber?
I know inequality, like few of the questions, I don't know exactly what the method is, but we're learning this method in school to solve it, but it's a bit confusing.
So, see, there are ways to do it. Any concept that we come across, It'll be new, it'll be confusing. And yeah, you got late by 26 minutes. But you, I'm sorry, you got?
We were driving in Chicago.
Okay, no, that's okay. Understood. No, so again, today we have less number of kids in the class, so that's why we are not learning anything new. What we are doing is, some kids had asked for certain things that I'm explaining. Yes, Mark.
My dad would never let me not skip this class.
That's
Just let me skip this class.
Please convey my gratitude to daddy, okay? Because I am not relevant if the kids are not in the class, trust me. The only way I can be relevant when you guys are here, I'm able to do something to make you guys learn something. So please pass on my gratitude to parents, and I have no shame in acknowledging that I'm nobody. Nobody knows me. I'm not even a qualified teacher. I was a good student when I was young as you guys. I'm just trying to pass on what I know to the generation after me. That's all. So if the parents don't trust me, if your kids don't trust me, I'm not relevant. Yes. Yes, please. Yeah. So, Manas, I will repeat my story one more time. And then I don't have magic wand, that is a guarantee. I will just tell you how things work, how you relate to it, and then you have to do what. Tell me honestly, how many times you have bothered to watch the video of the class?
At least twice.
Twice for every class? Or only 2 times in the lifetime? Okay, so again, I'm not picking on you. What I'm saying is this video is meant for a purpose. There will be something that will not be clear. When you're watching the video, don't watch it as if there's a game happening on the TV, there's a old man talking on the video, and there's Mr. Beast playing on my phone. If you're doing it all together, my guarantee is you'll not understand anything. What I'm saying is, if you're watching the video, watch it slowly. Okay, what did this person do? Okay, he put an equation x equal to 8, and then he tried representing this on the coordinate plane. What did he do? He explained, okay, every point on this line is having x value as 8. Okay, that was the first point. Then he said, okay, let's look at 2 variables, x and y, so that we can relate to it. And he first started with x plus y equal to 8. Just an example, meaning x and y value together will give me 8. There could be multiple things. When x is 1, y is 7, x is 2, y is 6, x is 3, y is 5. And I remember you were responding to it when I was saying, okay, if this x value is this much, what is the y value? So I created this table and I identified those points on the coordinate plane and joined that. It's a line. But that was not our agenda. Our agenda was to see what happens if this is inequality, not equal to 8, less than 8 or greater than 8. So we are saying, okay, since this is not equal to, if it was equal to, this was the line representing this equation. It is less than. That means this is certainly not the line. Am I talking about this side of the things or this side of the things? We randomly picked a point here. Minus 20, comma 0. This is minus 20. X value is minus 20, y is 0. Plug that here. Oh, that was satisfying. Minus 20 plus 0 is minus 20, which is less than 8. So that satisfies the condition. But am I talking about only one point? We picked up randomly a few more points on this side. And then we saw that, okay, all these points are satisfying this condition. That means I'm not talking about a line, I'm talking about a region. And I want to play more. I will say I will pick up a point minus 30, comma 10. Let's plug it here. Minus 30, comma 10. X is minus 30, y is 10. That is picked at minus 20, which is less than 8. Satisfies. So when you are looking at inequality, it represents a region. And I'm not saying that you have to always look at things below this when it is less than. You can also, you are actually validating. You pick up any other point on this side and see if that is satisfying this condition or not. If it does, you chose the right region. If it does not, this is a region. Yeah? You will have, see, I can only do as much I can do. I would certainly want you guys to watch the video of the class, make your notes to compile the way you understood things, and then solve few problems. I gave x plus y equal less than 8. You will say, okay, fine, why to stick to this? Let me pick another inequality, 2x minus y equal to 3, greater than 3. Everything will remain the same. Your first thing you will do is, okay, let me convert this to equal to and create this table for different value of x, and then try plotting this on the coordinate plane. Once I have plotted the line by connecting these points, then I will go back to my original ask. Okay, it has to be greater than 3. So am I talking about this region or am I talking about this region? So you can randomly pick some point, look at the x and y value, plug it here and see if that satisfies the condition or not. That will be your go-to approach. If you think that I can do some magic in the class and you will come out with flying colors, that's totally wrong. I have not gone to that level of teaching where one class does magic. Math is all about practice, okay? Please don't get me wrong. My only thing is I will explain things in the simplest possible way, and then you have to revise, interpret, comprehend that in your own way, make your own notes, then practice some problems. That will become your concept, then being your teacher's concept. Does it make sense?
Yeah.
Yeah? So anything you do in the class, anything I teach in the class, that is only 20% of the work done. Other 20% is by watching the video. Keep your hands away from the speaker, from the screen. Somebody muted me in between. What I was saying was, whatever I do in the class, that is only 20% of the work done. Remaining 20% is by watching the video, that makes it 40%. And rest 60%, which is the major chunk of it, is practice and the assignments. 10% is assignment, remaining 50% is where you play with things. This math class is not saying, oh, genius math. I'm not saying that. This math class's name is Math Made Fun. And that fun comes with practice. If you don't do practice, the fun is taken out. Yeah? Wonderful. Let's move on. So we'll talk about quadratics. I'm not giving you different flavors of it. Watch it, compile your understanding, solve few problems, cook up some problems by yourself. This is not the only example. You can say, okay, how about x by 2 minus y by 7 equal to minus 2? It is still linear equation because equation your variables and maximum power is 1. That's it. Play it the same way.
So, if the powers are greater than 1 or less than 1, will it not be linear anymore?
No, it will not.
Okay.
And we'll see that. That's what Gurshan and you both asked for, right? So, Anay, are you with me so far, Beta? I know you joined a little late, but I was just catching up on inequality concepts and how do you relate that to interpret it. Yeah?
Yeah, I understand.
Okay. So, in this class, since I had given this option to all the kids, so Gurshan and Suchit said that they want to understand what quadratics. So we'll talk about quadratic equations and see how much you guys are able to process this, okay? Because quadratic equation is something that comes in SAT also. That means the next level of that is coming for 10th and 11th graders also. So some of the things might be a little loaded, but I will try to keep it as simple as I can. Yeah? First of all, if I ask what is a quadratic equation, what is that you guys know? Let me hear it from you guys first. Anybody? Yeah, Gushan, go ahead.
The equation is x squared plus bx plus c.
Okay. So it's not x squared, it is ax squared plus bx plus c. Yeah? Now you guys will say that, okay, this teacher kind of memorizes things and then says, no, this is our concept now. I have dealt with it so much so that I remember it. So that's the standard form. Ax squared plus bx plus c. equal to 0. This is the form of a quadratic equation. This is a standard form. But let me not go here straight away. Okay? Let me give you guys a flavor of it. Let's say I have y equal to x squared plus 4x plus 4. Okay? And we want to know, so here if I look at it, this is again any equation that you come across, it is nothing but a contract or the agreement between the variables. Here what are your variables? Y and x. If I cook up a story out of it, how would I read it? It is saying that the value of y is equal to square of the x value plus 4 times the x value plus a constant. Okay? Manas, be on mute. You will only unmute it when you have to talk, because I am hearing some background noise that gets me distracted. Be on mute, Manas. Yeah. When you have to ask something, you will raise your hand and certainly let you talk. Anil, you are able to hear me okay? See the board okay?
Yeah.
Okay, cool. So I'm putting an equation here, y equal to x squared plus 4x plus 4. Okay? For me, it doesn't matter. I don't really care about things. I'm a very laid back guy, very ignorant person. I only know one thing in my mind. If I have an equation, it simply means this is the agreement between x and y. If x and y are two friends, they are saying that square of value of x plus 4 times the value of x plus 4 will be equal to the value of the second friend. That's it. If this changes to y square equal to x square minus 9, for me, I'm still being equally ignorant. I'll say, okay, for me, this is a contract between x and y, where y square of the value of y is equal to square of the value of x minus 9. That is how I'll treat it. If tomorrow it becomes y equal to x cubed plus 4x squared minus 7x plus 29, I'm still chilling out. I'm not worrying about it right now. I don't get scared by seeing the powers on this equation. For me, the simple understanding is, this is a contract between x and y which says value of y is equal to x cubed plus 4 times x squared minus 7 times the value of x plus 29. You keep putting value of x and you'll keep on getting corresponding value of y. That is how I look at it. But being ignorant is not good. Let's come to the important part of it. Let's try deriving something out of this one. A few minutes ago, when I was talking to you guys, I said, okay, what is a linear equation? A linear equation is an equation between x and y, where the maximum power to any of the variable is 1. What changed here? Power is 2, more than 1. This is certainly not going to draw a straight line for us. This is not a linear equation anymore. I have two variables, x and y, but the maximum power to one of the variables is more than 1. This is not a linear equation. Okay? This is called a quadratic equation. When the maximum power to one of the variable is 2, it's called quadratic equation. Does it make sense? So what happens in this case? When we are looking at this as a quadratic equation, what exactly happens? Nothing will change for us. I can still plot a table here, x and y values, and I will put some values here, okay? Let's say, let me put a little easier example to begin with so that you guys don't get scared in the first go. Let's say x square minus 5. This is still a quadratic equation because the maximum power to one of the variables is 2. So this is still a quadratic equation. Now let's see, for me it's a contract between x and y. When x is 0, what happens? 0 squared is 0 minus 5, y is minus 5. When x is 1, what happens? 1 squared is 1, minus 5 is minus 4. When x becomes 2, what happens? 2 squared is 4, minus 5 is minus 1. Okay. What happens when, let me play with some negative numbers. In place of 1, I will use minus 1. When I put x equal to minus 1, minus 1 squared is 1, minus 5 is again same minus 4. When I put x equal to minus 2 also, minus 2 squared gives me a plus 4, minus 5 is minus 1 again. Now I have few points. Let's try drawing it and see why it is not a linear equation. Let's say 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4, minus 5, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. Now 0 and minus 5. So x is 0, y is minus 5. I'm looking at some point here. Okay. When x is 1, y is minus 4. When x is 1, y is minus 4. I'm talking about this point. When x is 2, y is minus 1. So when x is 2, y is minus 1. I'm looking at this point. When x is minus 1, I'm coming here. Y is minus 4. So when x is minus 1, y is minus 4. When x is minus 2, y is minus 1. When x is minus 2, y is minus 1. Oh, what did we get? It's called parabola. Yeah, yeah. Yes, good son.
I was gonna say it's called.
It's parabola, right? So the first thing that we got was, as soon as you see any of the variable has a power more than 1, it is not going to draw a straight line, and we have a clearly visible example here.
What if it's less than 1?
Less than 1 also gives the same problem. Okay?
Sir, can I go to the bathroom?
If I say no, what will happen? Go for it. Go ahead. Anna, are you with me so far?
Yes.
Now, let me muddle the water a little bit more. We just looked at this equation and we saw that it's not drawing a straight line, it's drawing an inverted bell for us, which we are calling as parabola. Correct? How about, I'm trying to say, if I try to find out this equal to 0, meaning when the y value is 0, or I'm looking at the points where this parabola will touch the x-axis. That is where the y will become 0, right? So you are actually trying to solve for this. Under what circumstances or for what value of x your y will be 0. So this is the first example where we are trying to solve for x from a quadratic equation. What you did was, you said, okay, if y is 0, meaning when my quadratic equation, which was earlier y equal to x squared minus 5, when my parabola is touching the x-axis. Because these are the 2 points when y becomes 0. So if you are trying to solve it, you will say x squared minus 5 equal to 0, or x squared equal to, this minus 5 becomes plus 5 here, right? You will say plus 5 here, plus 5 here. That's how you have x squared equal to plus 5. Or x equal to square root of 5, which gives you plus and minus 5. Yeah? So you solve your first quadratic equation, and when you are solving your quadratic equation, what you did was you made the y component 0, meaning what are the values of x when y is 0, or what are the points on the coordinate plane when my parabola is touching the x-axis. Yeah. Now this became our go-to plan for dealing with quadratic equations. So Now you can look at different kinds of quadratic equations and start falling in love with quadratic equations. Let's look at it. I can have, let's say, a situation like y equal to 2x squared plus 7x minus 9. This is a quadratic equation because the maximum power is 2. You can have y equal to x squared, also a quadratic equation because this is a variable x which has maximum power 2. You can have y equal to minus x squared minus 7x minus 99, also a quadratic equation, because what you are concerned about is only the maximum power to one of the variables. Yeah. And in all cases, it will draw a parabola for us. And I will let you guys play with it whenever you have time. When you get bored, right? Pick up a math problem. Say, let me see what happens here. Let me prove my teacher wrong. Okay? Try doing that. Trust me, I love that kind of a debate with my kids. I am teaching some concept to you. I want you guys to try something and say, okay, let me see if I can prove my teacher wrong. That will be my biggest achievement for the day. And when you are doing that, actually you are confirming your understanding. And there could be something that I am teaching wrong. That we can fix, right? I mean, if that comes as a message to me, I can fix it. And that will be beneficial for you guys. And if you are not able to prove me wrong, which will be the case 99% of the times, because I prepared and I have practiced enough math, but when you are trying to do that, you are actually reaffirming your understanding and you are making sure that what you know it right. Yeah? Alright, so now coming here. So these are the different ways of, and these are some of the examples of quadratic equation. And in all cases, it will draw a parabola for us. When you are trying to solve for x, what you will do is, you will say, okay, let's find out the situations under which this parabola will touch the x-axis. That is exactly what we are trying to do. Okay? And there are different examples. So that is why there was a standard form that was defined for a quadratic equation. That's what Gulshan was talking about. Saying that this is defined as the standard form of a quadratic equation. Ax squared plus bx plus c. Now you can try marrying this with any other equation that you see here. If you look at this first equation, what is the value of a? That is 2. What is the value of b? That is 7. What is the value of c? Minus 9. Yeah? Look at the second equation. What is the value of a? 1. What is the value of b? It was actually 0 into x. That is how there is nothing with x. Your b is 0. What is the value of c? That is also a 0. So you actually have this, you can rewrite this equation as x squared plus 0x plus 0. And you can map this with this standard form. So standard form gives you a method to the madness. You can relate things. Where a is your coefficient of the term with x squared. B is your coefficient of the term with x. C is your coefficient, or C is your constant actually. Yeah. That is how we can relate a standard form of the quadratic equation with any quadratic equation that we come across. And if I say that we have covered everything, no, we just touched the tip of the iceberg. Before I go deeper into it, how do you solve a quadratic equation? I don't know, it might be a little bit overwhelming for you guys, but let me give you guys some basic techniques. At least at this age for you guys, you need to know about something that helps you solve quadratic equation in an easier way. There are 3 ways to do it. Okay, one is called the quadratic formula that you will probably learn in 9th grade or 10th grade. There is something called mapping with algebraic identities. That's what we'll talk about because that's important. And the third one is a magical formula for factorizing your quadratic equation.
Use like the
A times C equal to
okay, yeah.
breakdown of B. So let's not rush for it. Let's look at the simplest thing that we want to learn, or that we should learn at least at this time during spring break. Yeah, this is one of the very important agenda I have for you guys, as I see you guys growing, right? And this is something that I will inject in your brain at the right time, not in a hurry. But there's something called algebraic identity. These are the 3 formulas that you would need to learn now for the rest of your life. Have you seen these formulas before? Yeah? Yes or no? You're saying something. Don't be shy.
Oh, yeah, I'll just say yes to see the formula.
Yeah. So there are 3 formulas called algebraic identities or algebraic formulas. These are like the backbone of algebra. A plus b whole square equal to a square plus 2ab plus b square. A minus b whole square is a square minus 2ab plus b square, and a square minus b square equal to a plus b to a minus b. And you guys must be thinking, from where did it come all of a sudden? Because you're seeing something with a square, something with a square. So this has some relationship with quadratic equation, okay? I will not disclose that right now. Let me first show you guys, okay? You don't have to memorize it because I'm saying so. There is some method to the madness here. If I'm talking about x, I'm talking about only x. If I'm talking about x squared, I'm talking about x into x. If I'm talking about x cubed, I'm talking about x into x into x. Correct? So, if I'm talking about a plus b whole square, I'm actually talking about a plus b times a plus b. Correct? Now, there's something called distributive property. Okay? If I have to multiply 15 by 5, okay, what I can do is, I will say 15 is 10 plus 5 and then multiply by 5. Is that correct?
Yeah.
And then what you can do is, okay, 5 into 10 plus 5 into 5. So what I did was, everything that I had outside the bracket, outside the parenthesis, I multiplied each term one by one. That is how I'm distributing this. It's called distributive property. Is it getting a little too overwhelming for you? It's okay. Okay. Switch it is thinking. That's the reason why I keep asking kids to be in the classroom or keep their videos on, because when I look into your eyes, I get the right signals. Am I making sense or not? Or I'm not? Right? So this is thinking, right? 15 times 5. If you know the table of 15, you'll say 15 times 5 is 75. I'm saying 15 I can break it to 10 plus 5. Multiplied by 5. Now look at this. 5 into 10. This will give you 50. 5 into 5 will give you 25. 50 plus 5, 25, 75. Same thing. So you are just distributing it. You are just breaking it down.
So then how are we going to use it with the formulas that are up there?
So here if you see, this into this, a plus b whole square is, this whole thing is getting squared. This itself with itself one more time. So what I will do is, this can become this times the whole thing plus this times the whole thing. Like we did 15 into 5. What did we say? 15 is 10 plus 5. Let me be a little more playful. 15 I can write as 5 plus 5 plus 5. Is it okay? To be multiplied by 5. This 15 I split in 3 parts. That means this multiplied by this multiplied by this, and this multiplied by this. So treat this as one thing. So a plus b into this thing. So that means this thing into this thing plus this thing into this thing. That's what I did here. Now you have only broken half of the brackets. You still have some parentheses here that you are not liking. You want to get the alphabets out of the cage. Yeah? And you'll again, so now if you have this, you'll say this into this plus this into this. So this one is open now. Now let's open this cage. So this into this plus this into this. So this becomes plus B into A, B into A, plus B into B. Yeah? C.
Sir, what did that say? It says A times what?
A times B. See,
No, start the beginning.
A times A plus A times B. A times A is here, A times B is here. Now I'm going to this bracket. B times A plus B times B. Yeah? Now when I have, what is that? Okay. A times A, nothing but A square. A times B, I will call it AB. Yeah? Now B times A or A times B, 3 times 5 or 5 times 3 are the same thing, right? So A times B or B times A, I will call it the same thing. So let me call it B into A also as AB. Plus B into B is a B square. So A square and B square. And what you have here? One AB here, one more AB here. That is A square, and these two will get combined to become 2AB. If AB is banana, you have one banana here, one more banana here, 2 bananas. That's what I did. Now look at this. A plus B whole square is A square plus 2AB plus B square. That's exactly what I was saying. Yeah? Kian, are you with me, beta? Kian was hiding from me by going under the table. Don't do that. Okay.
It's a little bit complicated, but I get it.
So, see again, as I keep saying, there will be things that will come your way. And it might not sound easy in the first go. Even if I am trying my level best to keep it simple, maybe in the first iteration you might not get it. That's why we have a reusable video that you can watch. See, you don't have to worry about watching the entire video. If this particular thing is bothering you, watch it from the beginning. Okay, let's see what he did. A plus B whole square is A plus B into A plus B. So he's treating this as one thing. Okay. Now if I have this to be multiplied by this, let's treat this as one number, one value. That means this getting multiplied by this and this getting multiplied by this. Like it multiplied 15 and 5. Now that means this getting multiplied with this and this getting multiplied by the whole thing. That's what we have here. Now we are just trying to break open the cages. How do you break it? This multiplied by first thing, this multiplied by second thing. Okay. This multiplied by the first thing, this multiplied by the second thing. Okay. And then we are just adding them up. Yeah. So I just showed you guys one formula, and what I will do is in the next class when we meet, I will show you the importance of one formula. I know it's a little too early for you guys to digest this. Okay? That's why some of you are grappling to figure out what exactly is going on. And that's okay. Let the teacher create the stress. That's fine. You try simplifying it. So what we'll do is we'll look at this equation and I'll show you guys how to solve one simple quadratic equation using this equation. Okay? Because we just saw that, okay, this formula is not to memorize, actually it's derived. That is my style. When I'm giving you guys any formula, I feel morally obligated to explain you how that formula came into existence. Otherwise, you will think that, oh, this guy keeps on giving surprise after surprises and we don't know what's happening behind this. So that's why I always tend to, don't do that. No cracking sound. I'm almost done. So when you have any formula that you come across, I always try to explain that. Okay? Because if I don't do that, it will get more confusing. Now at least we can believe that this A plus B whole square is nothing but A square plus 2AB plus B square, and some of you who are not clear, I request you only to watch this 10 minutes of this drama, one time, 2 times, then try doing the scribbling by yourself, and then it will start making sense. Yeah? Because this is, as I said, these are the building blocks of algebra. So when you are venturing into this algebra space, this will be a savior, one of the saviors. Okay? This will let you enjoy algebra more. Okay?
Sir, so let me get this straight. A plus b squared in bracket square equals a squared plus 2 plus b plus b squared.
The way you read this is a plus b whole square.
So
A plus b whole square equal to a square plus 2 times a times b plus b square. Whichever way you memorize it, whichever way you practice it, I'll leave it to you guys. Because everybody has their own technique of memorizing things. I have only dirty techniques. I will let you guys explore your own enjoyable technique that you like. Okay? With that being said, I'll let you guys go. Enjoy the rest of your evening and enjoy the remaining days of spring break. And I will come back to haunt you guys on next week.